angles in standard position in quadrant 1. First, we're going to look at which one is quadrant 1. So if you look over here at your coordinate plane, your x and your y axis, quadrant 1 is right here. So we're going to look at standard position of angles in quadrant 1. So if we have an angle and it's angle theta, to be in standard position means that it has to be measured counterclockwise from the positive x-axis. So this is our positive x-axis, and it's going to be measured counterclockwise from that point. So this is an angle that is in standard position. From this angle, we know that we have a point. So the terminal point right here is a P of x and y, so it's some point. That means that the length from here to here is x, and the length from here to here is y. The terminal arm is the ray that is made from the origin, so from the center here, across to point P. So we're going to call this R. If we want to find the length of R, as you see, we have a right triangle, so we're just going to use Pythagorean theorem. So R squared is equal to x squared plus y squared. Let's take the square root of both sides. So R is equal to the square root of x plus y. X squared plus y squared, sorry. So this is our length of R. So if we wanted to find all of our primary trig ratios, so our primary ratios are sine, cos, and tan. And if you remember SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Just so you remember SOHCAHTOA. So when we do this, we're going to just use our variables. So tan of our angle theta is equal to our opposite side. So here's our opposite from our angle. This is our adjacent. And this is our hypotenuse, which is always across from the right angle. Tan is opposite over adjacent, so y over x. Cos theta is equal to adjacent, which is x, over hypotenuse, which is r. And sine theta is equal to opposite, which is y, over hypotenuse, which is r. So these are our primary trig ratios. If I wanted to write x in terms of r and theta, what that means is we want to have our x, our r, and our theta. So that means we have an adjacent and a hypotenuse. So we're going to go cos of theta equals adjacent over hypotenuse. And because we want to get x in terms of r and theta, we want x by itself. So we're going to times both sides by r. So x is equal to r cos theta. If I wanted to do y in terms of x and theta, or r and theta, sorry, we would do the same thing. So but this time we want y and r. So we're going to use sine because we have an opposite and hypotenuse. So sine theta equals y over r. Multiply both sides by r. And y is equal to r sine theta. So instead of writing our point as p xy, we can also write our point as p of r cos theta, comma, r sine theta. If we were giving the point 3, 4 on the terminal arm in standard position, that means that this point right here is 3, 4, and because we know that our x is 3 and our y is 4. So first we're going to determine the length of r. So we want to find our r right here. So we are going to go r equals the square root of 3 squared plus 4 squared. 3 squared is 9, plus 4 squared is 16, so 9 plus 16 is 25. So the square root of 25, which is 5. So we know that r is 5. Now that we have all of our lengths, we can find the trig ratios. So our trig ratios are tan theta, sin theta, and cos theta. So tan theta is our opposite and our adjacent, so 4 over 3. Sin theta is our opposite and our hypotenuse, so 4 over 5. And cos is our adjacent, which is 3, over our hypotenuse, which is 5. If we want to find the measure of theta, you can use any of the trig ratios. So let's use tan. So if we have tan of theta equals 4 over 3, we want to take tan to the negative 1 of both sides. So this cancels out. So theta is equal to tan to the negative 1 of 4 over 3. Type that into your calculator, and you get 53 degrees. If we want to write our x and our y in terms of r and theta to find our different point, we go x equals r cos theta, which equals 5 cos 53 degrees. If we want our y, it's r sin theta, which equals 5 sin 53 degrees. Now let's try example 2. So a forest ranger sees smoke rising from a point that lies in the direction east 40 degrees north. She estimates that the distance from the ranger station is about 30 kilometers. The firefighters at the ranger station have to travel east and north to get to the fire. To the nearest kilometer, how far should the firefighters travel in each direction? So we know that she's going, if this is our coordinate plane, north and east 40 degrees north, we know that this angle right here is 40 degrees. And we also know that she's 30 kilometers away from the ranger station. So this distance right here is 30 kilometers. We want to find this point. So we are going to write in terms of x and y with r and cos theta. So x equals r cos theta. Our r is 30, and our degrees is 40 degrees. If we type this into our calculator, round to the nearest kilometer, we get 23 kilometers. And for our y, we have r sin theta, which is 30 sin 40 degrees. Type it into your calculator, and you get 19 kilometers. So we know that they're traveling 23 kilometers east, then 19 kilometers north. You can use the Pythagorean theorem and the trig ratios to find trig ratios for many angles. So we're going to use the following. So it's a 45-degree angle, and the length from O to Q and to Q to P is 1. So first thing that we want to do is we want to find our length from O to P. So OP equals the square root of 1 squared plus 1 squared, which equals the square root of 1 plus 1, which is 2. So we know that this is the square root of 2. So now to find our trig ratios, this is our adjacent, this is our opposite, this is our hypotenuse. So tan of 45 degrees is equal to opposite over adjacent, which is 1 over 1. So tan of 45 degrees is equal to 1. Cos of 45 degrees is equal to adjacent, 1 over hypotenuse, which is root 2. And sin of 45 degrees is equal to 1 over root 2. These are really important to remember and how to find them. You can do the same for an isosceles triangle. So in an isosceles triangle, we have a 60-degree angle. That means that our remaining angle is 30 degrees. So we call this 30, 60, 90, because we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. So first what we're going to do is we want to find the length of AM. So if we were to use our Pythagorean theorem, we would go 1 squared plus AM squared is equal to 2 squared. Subtract 1 squared from both sides. AM squared is equal to 2 squared, which is 4, minus 1 squared, which is 1. So AM squared is equal to 3, square root of both sides. AM is equal to the square root of 3. So we know this length now. So what we're going to do is we're going to find our ratios for both 60-degree angles and 30-degree angles. So first, tan of 60 degrees is equal to our opposite, which is root 3, over our adjacent, which is 1. So tan of 60 degrees is equal to root 3. Sin of 60 degrees is equal to our opposite, which is root 3, over our hypotenuse, which is 2. And cos of 60 degrees is equal to our adjacent, which is 1, over our hypotenuse, which is 2. For 30 degrees, we have tan of 30 degrees. So now we're going from this angle. Our opposite is 1, and our adjacent is root 3. Sine of 30 degrees equals our opposite, which is 1, over our hypotenuse, which is 2. And cos of 30 degrees is equal to adjacent, which is root 3, over hypotenuse, which is 2. We can find the coordinates just by our r and our angle. So if we want to find the coordinates of a terminal length of r, which is 6 and 30 degrees, we know x is equal to r cos theta, and y is equal to r sin theta. So we're going to fill them in. Our r is 6, And now we're going to use our trig ratio. Instead of writing cos theta, we're going to write the value of cos theta, which is root 3 over 2. So we have 6 root 3 over 2, which simplifies to 3 root 2. Now for our y, we have 6 times 1/2, so 3. So our coordinate is 3 root 2, comma 3. For 45 degrees, we do the same thing. So x equals r cos theta, y equals r sine theta. So our r is 6. Now cos theta is 1 over root 2. So 6 over root 2. Same for y. 6 times 1 over root 2, which is 6 over root 2. So our coordinate is 6 over root 2, comma 6 over root 2.